Okay, so let's take a look at how the shock cord attaches. The shock cord that I have here now is the Kevlar cord. Again, this is the 300-pound. It's 1.3 millimeters thick, and this I like using this when I move up to this size rocket. For the T rockets, the tiny rockets, and the A rockets that generally run on the A's, those I usually like to use the 0.8 millimeter 100-pound, but the 300-pound is easier. There's a couple reasons. The 300-pound is in here because not for the strength, but the fact that the ejection heat is going to be constantly rubbing against it, and eventually it does wear. Kevlar is not indestructible, but it is heat resistant, but it will tend to fray a bit after a while, so I like using the thicker cord. Now this particular cord, you see I have it wound tight and keep my finger on it because it tends to spring apart, and that's intentional. I think it will, okay, it's going to hold. Okay, so this is a 6-foot cord, and there's a special winding technique that I have to cover, that you can take the cord, wind it up extremely tight like this, and when it ejects, it just snaps apart into a completely straight line. And one thing I had a lot of problems with was trying to figure out why my lines were always getting tangled up and why there's so many knots. So I solved that problem. It's another problem that we have to solve with these recovery systems. So these two loops that we have, this loop attaches to the nose cone. It's very, very small. We don't need a large loop there. Matter of fact, we want to keep this small, and I'll show you in a moment why we want to do that. This loop has to be larger because we have to pass the nose cone through it in order to tie it on to the end. So that's this cord. I believe this cord is 6 feet long, one large loop, one small loop. I'm going to be building that a little bit later on. This is actually a piece of heat shrink. However, it has not been shrunk. What I do is I put this over this knot, and then after I put this through the eyelet, I pull this back over the knot, and I'm going to eventually push it onto the end of the swivel. Now, I do this because, as I've commented before, if you leave the Kevlar cord on here with a slip knot, which is what we have with the loop, it's going to unslip. This loop is going to unslip, and then it's going to tangle all in here, and then you lose the effect of the swivel. This allows it to keep the knot tight without it tangling. Another important factor is that it keeps it stiff down here so that it helps the swivel to spin without it binding too much. So it's very, very nice. It's a very small piece of this stuff. And again, we don't shrink it, because if we shrink it, we're not going to get this cord off. So the whole idea is that we can pull this whole thing apart when we're done. So you pull that off, and then we can untie the cord. So I'm going to show in a moment how we're going to tie it all back together. But let me show the last two pieces first. This part is the Kevlar blanket. This blanket holds the streamer. The streamer has a metal washer at the top. That's a number 8 washer. What's important is that there's a very unfortunate situation that occurs with the streamer, that the streamer, when it's up here, two things can happen. On acceleration, it slides all the way down to the bottom, and that plugs the rocket up. You fire the ejection charge, it can either blow the streamer into bits, blow the rocket into parts, or just get stuck and it doesn't come out. So we have to keep the streamer. Oh, another important thing is that if it slides down, it changes your center of gravity, and your rocket starts spiraling. I lost a few flights because of that. So what we have to have is a way to keep the streamer close to the top. So the way this works is this Kevlar blanket has this eyelet. This eyelet is going to eventually be tied to the nose cone. We put our streamer in here, and then this holds the streamer at the very top of the rocket. So that under acceleration, it's going to hold it, and it's going to stay put. And then when it ejects, it just opens up, and everything is just fine. There are two little holes on here. Actually, that's because I had recycled this from a previous streamer or previous blanket, and it had some holes in it. But that's not going to matter much. We're going to have some additional wadding in here besides having this Kevlar. The Kevlar is not the only thing that protects us. We do have to have some wadding, because ejection particles that come through, they'll hit this and they're still burning. So what it's going to do is going to burn a hole through the Kevlar. Even though it doesn't reach the streamer, it damages the blanket. So we still want to have some wadding in here. So again, this eyelet helps us hold this particular blanket very close to the nose cone. And I'll show you that in a moment. The final item is the streamer itself. I'm holding it with a rubber band right now because this material is very springy and it's going to pop apart. We can see the streamer fits in here and it flips right up, and we just slide this into the rocket. So it works very, very nice. This cord will be up this direction when we actually put this into the rocket. So this is how we snuggle the streamer in here, and it's very soft, very pliable. We just take this and just stick it into the body tube and it just slides right in, no problem. There are some equations that we can go over that determine this width and this length. It's easy to see. It's not. This is not rocket science. This is algebra. But if the streamer is 2 inches wide, that means this has to be at least 4 inches to go 2 inches here and 2 inches here. Then we know that this width is going to be the width of the body tube. So basically it's 2 inches plus the width of the body tube, and that gives us the length of our particular blanket. I add like another ½ inch to allow for the actual eyelet. And that's it. Again, it's not rocket science. This particular width here, this width needs to be at least the width of the rocket, and then I add one more width so that I have some room to fold it on the edges. So again, simple equations, but they're very easy to understand why I do that. Okay, this is the streamer. This is the most important part of the overall design. This particular streamer is a 2-inch one, and depending on the size that I'm using, which is 1 inch, 2 inch, or 4 inch, I change how I connect to the streamer material itself. The reason is that connecting to the streamer material is going to be a little bit different for each material, and also we have to deal with the actual width of the material. How this is done, if we look at this very, very carefully, you'll see that there's a toothpick in here. So this toothpick is in here. This cord is glued to the center of it, and then there's 2 tape tabs on the side. These 2 tape tabs then hold the actual leading edge of the streamer together. You can see I actually have the cord laid along the edge. Sometimes I leave it and tape it down. Sometimes I just cut it off. It's not going to make any difference. Once you tie the knot, you have to put a drop of CA glue on here, and then you have to let it dry for about an hour to get it extremely dry and hard. And then you can cut off this edge and just tape everything together. What's interesting about the tape, I'll show you the tape that I use. Oh, by the way, on the end of the streamer, there's another loop. This loop ties into this eyelet. I also commented in my emails that we have this Kevlar cord that ties onto the eyelet, and then the streamer ties onto the eyelet. So basically, all of the force yanking back and forth on the streamer is going to yank back and forth on the eyelet and then yank on the Kevlar cord. If you put this into the nose cone, I've had plenty of flights where the nose cone eyelet tore right off. So you don't want to attach anything to the nose cone that's going to provide a lot of stress. And this provides a lot of stress simply because the ejection happens, the Kevlar cord is going to unroll itself extremely fast, and then it's going to yank. Because this does not flex, it's going to yank really hard in the nose cone. Instead, here we have it yanking hard on this eyelet. And then once it yanks in the eyelet, it's interesting because this is still wound up, so it's going to take this and throw it. So it's basically like taking a long a spiral, and just if I take this and go, whoo, and throw it, it'll unwind quickly. That's effectively what's happening in deployment, that the streamers, or the blanket stops and the streamer is attached here, but the streamer then flies out, and this unwinds very, very quickly. So that's how I get my streamers to unwind very, very quickly. In making a videotape of this, it goes from ejection to full unwinding in about 0.2 of a second. Very, very nice, and everything completely unwinds. Okay, so that's the components that we have, and I'm going to do another video that shows how all these things tie together.